Hello all, very good morning. Thanks for joining the session. Let me share my screen. Um, Give me a moment. I'm sharing the screen. Hope you all now able to see my screen. I believe. Thank you so much for joining the Apache Kafka 4 weekends workshop. And today is the continuous session. That is May 25th. Is the continuous session, or you can consider it as demo 2 for the demo 1, which was happened yesterday. That is 24th May. So a quick recap. Yesterday, we discussed about the why Apache Kafka. I believe most of you people got the idea what the Apache Kafka is solving the problem. Meaning what problem the Apache Kafka is solving, right? So today we'll see what is Apache Kafka. So yesterday we have seen, right? If the direct producers are producing the messages or the events to the consumers directly, there is a chance of having the data loss. And one consumer can't consume the events from the many producers, or one producer can't continuously send the data to the many consumers. This is the problem. Data loss is one, many to many is the one problem. I think I I will show the document and then do a quick recap. Quick recap, not more than just 5 minutes. Okay. Yeah. Um, Perfect. So this is what we discussed yesterday, right? One to many problems, many to many problem is one, and then data loss problem is the second. Then what solution we applied? Database as the alternate solution we applied. Then the problem solved. Many to many problem has been resolved as many to one and one to many. And then there is no chance for the data loss because all the events produced by the producers will go and then store in the event store for a period of time or maybe permanently. That's up to us how we want to maintain it is. But the events will go and then sit in the event store. So we avoided the data loss. But here is the problem. What is the problem? Naturally, the database, we can't see it as a event store, streaming event store, because database underneath it is storing the data into a file, and that file is what? Mutable file. So if the producer produces three events, one is the create event, second one is the update event, third one is again insert event or create event, right? Let's say new record created, new record one created, new record two created, new record one updated. So three events happened. But in the database side, in the database table, we can see only two rows because the event one, whatever is created, the event one has been modified. So the only event one modifications we can see in the database, right? So three events occurred here, but consumers can retrieve only the two events, which is inconsistency and looks to be we are losing delivering the one event to the consumers, right? So this is the problem. So then what we have done? We have taken the advantages of the Apache Kafka because Kafka is following the same architecture by eliminating the mutability of the log file and by making the log file as immutable, right? As a result, how the architecture has been changed? The architecture has been changed like this. So now how many events, for example, event 1 is created, event 2 is created, event 3 modified. So the modification also considered as a new entry in the log file. So that's what it is, the immutable, sorry, yeah, it is the immutable log file. So now we solved the problem of the mutability in case of the database, by introducing a immutable log file, which is creating and then managing by the Apache Kafka. So how many events are producing by the producers? Those many events will be consumed by consumers. That's it. Problem solved. And and now the events will, however, store in the log file for a period of time. So there is no point in losing the data. I mean, there is no chance for the losing the data. And also, we can achieve the fault tolerance because if while consuming the event by the any of the application, if they got any error, they can retry for the same event processing that they can find in the database. Sorry, log file, I need to say, right? So the problem of the data loss avoided, the problem of the many to many avoided. Now one device can now one POS machine or one producer can produces n number of events to one storage location. It's not producing too many. It's not producing too many. It's producing to only one. So each device or each POS or each producer is producing the messages to only one storage location. Now, from the storage location, each consumer is consuming the messages of the event. So the problem of continuously delivering the messages by one devices to many applications has also been solved. That's the beauty of the Kafka, right? So this is what we discussed yesterday. Okay, now you got why Apache Kafka. Now let us see what is this Apache Kafka actually, where it came from, right? So let's see that one. Um, okay, fine. Now let's go and then see. Uh, okay, now go and then see what is Apache Kafka. Okay, so carefully listen, folks. Concentrate. Keep your questions aside. I definitely will answer all of your questions. What is Apache Kafka? We know Apache Kafka is solving the problem of the data losses and then the ingestion of the data. That means that continuously data is sending from one place to another place. So those problems were solved with Kafka. What is that Kafka basically? So Apache Kafka is an open source distributed event streaming platform. Open source, scalable, open source, scalable, distributed event streaming platform, right? So there are a lot of words we phrase together. So it's an open source. First of all, you can download, you can modify the source code if you want to customize according to your needs, and it's a distributed. That means Kafka broker we can set up in one instance, Kafka producer we can set up in another instance, Kafka consumer we can set up in another instance. Instance in the sense I mean to say the servers, or you can consider AWS machines. A broker can be on one machine, producer can be on another machine, consumer can be on another machine, right? And orchestrator, that is KRAP or maybe the zookeeper, is also on another machine. We can distribute these components. That's what we're going to see in the installation process. Okay, so that is the meaning of the distribution here. And now we need to understand this event streaming platform, what it is. But before understanding that, we will see little prerequisite content. Okay, so Apache Kafka is an open source distributed event streaming platform used by thousands of companies for high performance data pipelines. Right, high performance data pipelines. That means what if you can see the Netflix or Amazon Prime or Uber app or Ola, everywhere we'll see some use cases, payment gateways, payment integrations, or payment transfers, right? Everywhere, everywhere nowadays, this event streaming platform is using by the thousands of the companies. So if you can see the Kafka, here this is the Kafka broker. So Apache Kafka is a message broker. It's a message broker. Everything other than this message broker, like producers, consumers, connect, streams, everything is an API or a library. Apache Kafka is a broker. Everything which is connecting to this Apache Kafka, which is interacting with this Apache Kafka, is a library or a frame, right? So now Apache Kafka is a broker, and everything whichever is connecting or communicating with this Kafka broker is a library or a framework to to produce and then to consume the data from the broker. Okay, so the Kafka, you can see here, the Kafka broker is act as a man in the middle between the producers, between the consumers, with the three primary responsibilities. So this Kafka broker is sitting between the producer and the consumer. I believe if you can see this diagram, you will get more clarity. This one. So Kafka broker is sitting in the middle. Let me just, yeah. See, this Kafka broker is sitting in the middle, man in the middle, right, between the producers and the consumers with the three primary responsibilities. What are those three primary responsibilities? Receives the messages from producers and acknowledges the successful receipt of the message. So whatever are the producers are producing the messages or the events, right, to the broker, the broker will receives the events, and then upon the event received and then store, upon the event received, it will send the acknowledgement. And next is what? Stores the messages in the log file to safeguard the message from the potential loss, right? So it will save the messages in the log file, and and deliver the messages to the consumers when they request for it. So it delivers the messages when the consumers request. Now here you can understand one thing basically. This is see, this is see, this is what directly giving, like every producer is producing the messages directly to the consumer. Hence, if the consumer is busy, because consumer is not only a single point for the single producer, the consumer is a point for many producers. What will happen now if the consumer is busy in consuming the other producer's data? Then whatever this producer produced may last. Now that architectural problem has been resolved now by storing the messages in this log file and by making those messages available for the consumers to retrieve them at any point in time, or maybe later, not immediately, or maybe immediately, right? Maybe immediately, may not be immediately, or maybe later in time, the consumers can consume the messages because the Kafka broker is safeguarding the data which is producing by the producers, right? Now, what did you understand? What is Apache Kafka? Apache Kafka is just a broker. Simple. Apache Kafka is just a broker. And everything which is talking to this Apache Kafka is a API or a library or a framework, right? So now we got to know what is Apache Kafka. Now, Apache Kafka is horizontally scalable, fault tolerant, distributed event streaming platform. Now you understood distributed. You know now what is the broker, and horizontally scalable. Horizontally scalable in the sense what we can scale these. We can scale these into a different machines. What I told, right? Broker is on one machine, producer is on another machine, consumer is on another machine, zookeeper or the orchestrator is on another machine, right? We will see the Kafka architecture. So all the components we can align in different machines and make them to be interact. So that is what the horizontal scalable. Okay, and fault tolerant, you know how it is fault tolerant because the Kafka is providing the storaging of the log messages produced by the producers. That will avoid the fault tolerant, right? Now, to understand the Kafka architecture, we need to understand storage architecture, cluster architecture, and stream architecture. You, we can say work distribution architecture is what I have taken. We can add one more point here as a streaming architecture. So now let us come back to the definition. Apache Kafka is horizontally scalable, you understood. Fault tolerant, you understood. Distributed, you understood. Then, one moment. Horizontally scalable in the sense what? Many instances of the Kafka broker, we can, let's say, um, one easy to machine, we are running the broker one. Take one more EC2 instance and then run the broker 2 there. And take one more EC2 instance, run the broker 3 there. And these 3 brokers we can replicate. Meaning we can tie them together with a replication to replicate the data into a central log location. I think my words are little um, pure technical or maybe new to you. If you are confusing, ignore this word. Going forward, you will understand. Okay, perfect. Now, um, please ask your questions at the end of this one because we started understanding the. I'm assuming you all are new to Kafka, so that I'm starting from the very basic. So whatever the questions few members are asked, I'll answer those questions at the end of the session for sure. Or you can also enable your mic and then you can ask me the question directly. But please focus on the content what we are discussing. Thank you. Okay, now we understood the definition. Now we need to understand what is this event streaming. Very, very important. Very, very important. So for this one, if we can go to Apache Kafka official documentation. So from where I went to this docs and see here getting started and all, right? So if we can see the introduction, what it is. So let me just scroll a bit. So go to introduction. This is the official documentation, right? What it is saying. I'm just trying to explaining you the word called event streaming because it is very important word to understand. See what the official documentation is saying. Event streaming is the digital equivalent of human body's central nervous system. How beautifully he explained. See, event streaming is the digital equivalent of the human body's central nervous system. So it is the technology foundation for the always on world where business are increasingly software defined and automated and where the user of software is more software. What does it mean? With this event streaming platform, event streaming is what always on, continuously, always on, continue. How the nerves in our human body will work continuously, they will pump, right? They'll pump the blood and whatever they circulate and all. Like how continuously our nerve system will work, similar to that, event streaming also is a always on system. That's what he's talking, right? So, technically speaking, event streaming is the practice of capturing the data in real time. Real time. This is very important. Okay. Now, see, you will understand this. I'm doing or you guys are doing a NEFT transfer, and you guys are doing a what is that? IMPS transfer. which is real time. IMPS is the real time because as the moment you clicked on transfer, your recipient will receive the money, right? But this NEFT is what somehow it will take little time, maybe two hours or maybe 3 hours it will take. But we can consider it also real time. I mean to say real time in the sense on fly, continuous. It's a real time, continuous, on fly is what I'm trying to convey to you. Okay, so technically speaking, event streaming is the practice of capturing the data in real time. That means continuously, right now. Okay, the better example what I can take is whenever you are going in a car, you on your map. That is real time, right? As long as your car is going on, as long as your map is on, it will continuously show you the data. That's what the real time, right? So capturing the data in real time, event streaming is the process of capturing the data in real time from event sources. This is important. From event sources. Event sources can be a databases or sensors or mobile devices, cloud services, and software applications, etc. If you bind your Apple Watch with your Apple mobile phone, what will happen? Your Apple mobile phone will capture the real-time data of your Apple Watch, and it can show you the what are all the activities of the Apple Watch you can see in your Apple mobile. Those are all synced together. How? Why? Why? Because of these event streaming platforms, right? So similar cases, for example, uh, just let me scroll it up. Yeah, similar cases. Let's say cloud services, right? And then the mobile devices, sensors, right? And then the databases, right? So these are all what a couple of sources, or for names a few sources from where the data can be captured in real time, right? From where we can to capture the data in real time. Data source is also very important, correct? We can't use this Apache Kafka or maybe even streaming platforms in every aspect. There should be a there should be a use case. There should be a source from where you continuously get the data. If you don't have the source where you will get continuous data, there is no point in using the Apache Kafka or maybe even streaming platforms, right? So that's what I'm saying. So even streaming is the process of capturing the real-time data from the event stores. Okay, or data stores, we can simply say. Now coming back to our material. So what is an event streaming platform? In event streaming platform, there is one or more producers and one or more consumers, right? So one or more producers, one or more consumers will do what? Producers and then consumers will subscribe to this event streaming platform for the stream of records or maybe the data and store the stream of events. The streaming platform will store the stream of events and analyze and process events as they occur. How the data is coming in, it will analyze, it will process, it will make it available to the consumers. So simple. Even streaming platform, there is one producer, one consumer. Sorry, there is one or more producers, one or more consumers subscribing to this platform and then producing the data. Platform will store the data. That's it. The stored data can be analyzed and then the stored data can be processed by the consumers, right? Of course, event streaming platform also can analyze and then process the events as they occur. It will analyze what is this event. Analyze in the sense it have the mechanism. Like if you can take the Kafka, we have the topics, we have the partitions, replication factor, so many things, time index, so many things we have. So whatever the message is coming, it will process accordingly and then it will make it available to the consumers. That's the meaning of analyzing processing. You definitely get understand this material once we going forward with the sessions and all. Okay, so in a nutshell, we can understand this event streaming platform as this. So there is an order service, right? We ordered something. When we ordered something, then ordered event can be triggered to the event streaming platform so that the payment service can receive the order and then initiate the payment. And similarly, once the order is placed, it will go to a inventory service as well. Because from the inventory, we will place the orders. Let's say in the inventory, I have 10 Apple phones. So now I purchase 2 Apple phones. So inventory should be updated, isn't it? So once the inventory is updated, right, then the notifications will go to the notification service, right? Because if the product is not available, then the order can't be placed. Assume that's the case. So here the point is what, as long as the events are occurring, and then storing into the event streaming platform, the other side, the subscribers will go and then get them and then process them. Right? This is in a nutshell event streaming platform is. Now you understood, right? In the event streaming platform, what is the Apache Kafka official documentation is saying? Event stream is the process of capturing the real-time data from the event stores. That's what it is. It is saying. Meaning from a source, meaning there is a source for sure. From the source, we need to capture, meaning the event streaming is the process of capturing the real-time data from the sources, right? And then event streaming platform will do what? Event streaming platform will enables the event streaming, that is continuously capture the data from the sources, analyze the data as they occurs in, and then make them available, store them somewhere, and then make them available to the consumers. That is what the event streaming platform is. Great. Hope you understood, right? What is event streaming and what is event streaming platform? Hope you got it. Right. Now let's see some traditional messaging systems versus the Kafka streaming platform. So in traditional messaging systems, uh, here we're talking about messaging system streaming platform. Kafka is also falls under the messaging system. We are talking about now the differences between the other messaging systems like RabbitMQ, and then the differences between the Kafka event streaming platform. So basically, we are talking the differences between the messaging queues and then the event streams, right? So in the messaging system, transient message persistence will be there. What does it mean? Meaning the message once received by any consumer, this is the typo, here it should be consumer. Meaning the message once received by any consumer, the message will be deleted from the queue. Once the message will be received by the consumer, the message will be deleted from the queue in the traditional messaging systems. But Kafka, in the case of Kafka, Kafka stores the events in the file system, that means the log file, based on a retention time. By default, this retention period is 162 hours or 7 days. So it will store, let's say, this produce the event stored here. Event will store here for 7 days. If you don't configure it externally, it will store here for 7 days. And then the consumers can come back here and then get the data, anytime. Let's say analytics taken the event one. Still the event is available in the store. But in the case of the traditional messaging system, if the analytics is taken that event will be deleted from here. But Kafka doesn't do that. Okay, that's the difference. So Kafka is giving what? The persistence, meaning permanent, not permanent, retention message persistence. Kafka is offering retention message persistence, whereas the other traditional messaging systems are offering transient message persistence. Okay. Now, this in the traditional messaging system target to a specific consumer, but here any consumer can access a message from the broker, and it is not a distributed system. Here it is a distributed streaming system because of the pub/sub model. You may confuse 100% with these differences because you may ask me a question, sir, but RabbitMQ is a distributed one. We can distribute it. We can make it as a distribution. And RabbitMQ also doesn't target to a specific consumer. But if we can take some other messaging systems like ActiveMQ or maybe other messaging systems in the world, if we can take who falls under this traditional messaging system, for them these points belongs to. Don't confuse, please. Now, the only point between the uh, if you specifically compare the RabbitMQ versus the Apache Kafka, RabbitMQ is a messaging system. Apache Kafka is also a messaging system with a streaming platform. And you can see the easiest understanding how you can understand is, assume you are booking a cab from Amirpet to Kukatpalli, right? So once you book the cab, right, is that cab available to other riders for booking? No, it won't be. Listen my words carefully. You are booking a cab number 1234 from Amirpet to Kukatpalli. Once the cab booked for you, is that cab number 1234 is available for other riders also to book? No, it won't. That is what target to a specific consumer. Now coming to the streaming platform, Netflix you can say, or Amazon Prime you can say, you subscribe to a movie. Is it for you only? No. Lakhs of subscribers can go and then subscribe to that movie. That's what any consumer can access. Any consumer can subscribe and then any consumer can access. That's the difference between the streaming platforms versus the messaging systems. Hope you got it now. Okay, let me take a pause here and ask you a few questions. Is it clear so far? Do you have any questions on the topics what we discussed so far? You can unmute your mic and then talk to me. Any questions? Is it clear? Did you understand what is Apache Kafka?
Sir, difference between Kafka connectors and Kafka streams? Kafka connectors means?
Kafka, not Kafka Connect. Of course, we can say Kafka Connect API. Kafka connectors will helpful to go and talk to different source of systems. Let's say if you want to get the data from the RDBMS, let's say MySQL, we can go and then talk to it using the RDBMS connector. If you want to get the data from a file system, we have a file system connector. So Kafka Connect is the API to connect to the different source of systems, right? That is a connect. Now, streaming is what? Once after you connect it, then your streaming will start to consume or to get the data from that source of system. Got it? Am I answer now?
Yes, sir. Yes. You mean
Oh,
to say both are required in order to perform, I mean, in this ecosystem, right, sir?
absolutely.
Okay,
Absolutely.
thank you. Thank you.
Any more questions?
Sir, what do you mean by target a specific customer and any customer can access message from broker? What is the
Okay.
difference here both?
Okay. I mean, I explained one example, right? The cab booking example. When you book a cab from one place to another place, when once after the cab booked for you, will that cab available for anyone else in the same time to book? No. That is what a specific consumer. That means, let's say the app is analytics. Now the producers can produce only the messages to the analytics only. right? Not for the others. That is specific to a
Got it.
consumer. Yeah, got it. Okay,
So
fine.
how it will be differentiate like the specific means is there anything in the code level do we need to do something?
Not code level. That's what we will see. Meaning the product has been designed in such a way in the messaging system will use the queues. The queues are specific to a consumer, and in the queues again we'll create the topics to make it to a multiple consumers. But in the Kafka, we have only the concept of topics. So by the benefit of the topic, we can make it as a multi-target customers. So that's the
Got
creation of the topic and all is what the product has been shipped with the a couple of meaning APIs and then the boundaries and all. We'll discuss going forward.
Sir, but the
Okay.
topic is also available in Apache MQ and also in Rabbit MQ. But so, what is the difference between topic of Apache MQ and Rabbit MQ versus Kafka topic?
That's what I told, right? In the messaging system, we will create a queue, and inside the queue, to make it to a multi-target consumers, will create the topics, right? But in the case of this Kafka, we'll create the topics to make it, I mean, different topics will create. One topic for analytics, one topic for inventory, one topic for loyalty. We will create to make it as a multi-consumer target. So there, inside the queue, we will do. Again, the queue is what will target to a single consumer. So we will take the advantage of the topics part of the queues over there. But here, there is no queues concept here. Everything is a topic for us. One layer we are disregarding here. Got my answer?
In
Sir,
this,
topics can be replicated, sir. Topics can be replicated.
No, topic can't be replicated, but the data. Okay, good question. Topic can be replicated. No, topics can't be replicated. Topics are
Uh,
unique. The data inside the topics can be replicated with the replication factor. So there is a concept called replication factor, which enables the data to be replicated within the topic with the help of the partitions. Okay?
okay, sir. Okay,
Yeah,
okay.
you will get it.
Sir, yes, sir. One more question. If the streaming of the data, then order must be there, na, sir, actually. Order should be. The messages order, sir. First message, second message. Yesterday, Kafka doesn't maintain the order you said, na, sir, right?
What I said is messages doesn't follow the order, whereas the order we can achieve using the partitions is what I told. Okay, so that means what you can see this. You can see here. Meaning we are too early to discuss all these things, but as the
Okay, sir.
question,
Okay, sir. Okay, sir. Okay, sir. No issue, sir.
no,
You can.
no problem. I'll show you one more thing. See this. There is a message key. If we send the data without a message key, no order will be maintained. But if we send the data with the key, see A for apple, A for Adam, C for cat. If we send it with the key, then
Key,
the
sir.
order,
Key.
it will follow the hashing technique within the partitions. Okay, like
Okay,
how
sir.
hash
Okay.
you got it from. Yes, yeah. We'll discuss these
Okay,
all.
sir.
We'll see
Okay, sir.
that.
Okay, sir. Yeah. I think topics can't be replicated, but the partition replica set is there. Messages.
Exactly. Yeah, that again will be decided by the replication factor. We'll discuss. That's an interesting concept, replication factor. So there is
Okay,
a
sir.
yeah, I'll explain. Go ahead. Great.
Okay, sir. Thank you.
Sir, we have SQS and SNS in AWS. How different this one from them?
So basically, they are the cloud services, right? Pay as you go on. For example, if you can see the SQS, that is a queuing system, right? It is
Yeah.
it's a system, but not the streaming actually. It's a queuing system. Again, there may be pitfalls around it, like um, single consumer single consumer point, or maybe we need to add extra topics over there. So these are all, traditional messaging system pitfalls will be applied for the test views. But when you go for the Fyros is a streaming architecture again, which is follows the streaming platform. So the only point is what, streaming platforms have the data guarantee, data retention, which avoids the, uh, you know, these problems, fault tolerant problems. So that's the benefit actually. Now, as the question you asked, difference between SQS and the Apache Kafka, that's the messaging queue. This is the streaming platform. Streaming platform will be work like always on system. Messaging queue will be work like when the message will come, it will consume. It's will come, it will consume. But streaming is a continuous process, right? So to different use cases, based on the use cases, we have to go for either messaging queues or messaging systems. Meaning, I mean to say, messaging queues or maybe the event streaming platform. Based on our use cases, we have to choose whatever. If there is a continuous stream of data, go for event streaming platform, not for the messaging queues. Now, am I answering your question?
Yes, sir. So the next question is, let's assume you mentioned by default the message will be there in 7 days, right? Or 162 or something. So what happens if I read the message in between, I mean, during that time? It will still be there?
Yes. Let's say today message produced by the producer. That means, I don't know what is the time for it. I think it is, for me, it is 10:48. So 10:48 message came into the queue. Sorry, message came into the event store. Now 10:48 to next 162 hours, the message will be there. You can come and then consume at any moment of time. But after the 168th hour, meaning 168th hour, once it crashed, then it will discard the message from the log file, meaning the storage. Got it?
Yes, sir. So during this time, any number of times we can read the message.
Exactly.
So there is a possibility that the message can be read multiple times or duplicate times, right, sir? The same message can be read multiple times. How can we avoid the duplicate read?
That's the application side we need to take care of. That is the important interview question as well, basically. Because, in order to answer this question, we need to be complete these Kafka storage architecture. You need to understand partitions, replication factor, segments, offset index is the answer for your question. But if I starting explaining now, I may be deviate from the concept, right? But for your answer, there is a offset index using which we can avoid the duplicate reading of the data. Something consumers have to take care of it. Of course, we can't enable it at the broker side. Consumers have to take care of it actually. Got it?
Yeah, thanks, sir.
Perfect. Okay, without any deviations, let us continue now. Excellent. You are, receiving the whatever I'm delivering. Great. Kumar, sir, please repeat stream versus messaging platform. Okay, let me again repeat. Messaging systems. Okay, only in a simple words, I'll try to explain. Messaging systems can't persist the messages. And once the messaging system assume this is the messaging system, there is no persistent mechanism in the messaging system. So producer produces the data and it will be consumed on fly by the consumer. So there is no storage here. If the consumer failed to consume, then it will be meaning we have to configure the messaging system in such a way it should have to go to somewhere else, or maybe kind of DLQs, or if the consumer fails to consume, Sometimes we also will lose the data because there is no storage of it. Replay or retrieving is not possible in the messaging systems because there is no storage, right? But in the streaming platforms, we have that. Okay. And messaging systems are targeted to a specific consumer. That means the producer can produce the data to the messaging system, and that data can be taken by consumer. If the data will be consumed by this consumer, then that data won't be available for another consumers. Because once the data consumed by a consumer, that's it. The data will be taken off from the, the messaging queues. Right? You got this point, right? So once the producer produces the data to the queue, and once it received by any consumer, if it received by any consumer, then it will be deleted from this messaging queue so that it won't be available for the other consumers. That is the point of the single consumer, specific consumer. But Kafka streaming platform is not, right? It will be for the any consumers. So because we are storing it, if consumer analytics consumed it, still the message is here. So loyalty can still read it. Okay, so that's the difference. And not a distributed system is a distributed system. I don't really align with this point because we also can make the messaging queue as a distributed system. But I'm talking about few other messaging systems like maybe ActiveMQ. They are not the distributed. I mean to say distributed in the sense that the components of the architecture we can't put in different places. For example, ActiveMQ we can take. I think ActiveMQ we can ActiveMQ we can, but RabbitMQ we can't. ActiveMQ we can distribute, but RabbitMQ we can't distribute, I believe, because there is no orchestrating model in the RabbitMQ. Okay, so that's the differences. Hope you got it. Yeah. Okay, great. So you are following everything. Thank you so much. And let us go for the Kafka use cases. So official documentation given the use cases. Let's go and let's see. See this. What can I use event streaming for? To process payments and financial transactions in real time. Here, real time meaning continuous. Real time meaning continuous. So to process payments and financial transactions in real time, such as in stock exchanges, banks, and insurances, will go for this event streaming concept. Second, to track and monitor the cars, trucks, fleets, and shipments in real time, such as in logistics and automotive industry, we can go for the event streaming platform, right? For example, as we said, Ola and the Uber, right? So they need the event streaming platform for sure. And for example, fleets and the trucks also, we need to track them where they are now. So we'll use a GPS model, or maybe we'll use some kind of IoT model, and that IoT will report the data to our event streaming platform, right? Then to continuously capture and analyze sensor data from IoT devices. So this is what I'm talking about, right? So we'll put one device in the trucks. Let's say while the truck is moving on, this device will report the data to our event streaming platform. So our event streaming platform will analyze those records and then make them available to the consumers to consume. So next, to collect and immediately react to customer interactions and orders, such as in retail, the hotel, travel industry, and mobile applications. For example, if you want to book a flight ticket, right, from maybe Mumbai to Delhi, or maybe from Hyderabad to Bangalore, you want to book a flight ticket, right? There, what will happen? There is a complex system all the way from this, all the way you start booking the ticket, the booking confirmation till you get the booking confirmation. Everything is an event stream, right? Everywhere, every system will know it. Correct? Once you book the ticket, reward system will know it. A loyalty point system will know it. And travel, the travel airlines will know it. Everywhere your message will be, your event will be spanned to everywhere, every target applications. Let's say I'm booking through an agent. Let's say I'm booking through the maybe make my trips, or maybe I'm booking through the some other agent, right? So when I'm booking, the copy of my event should always has to go and then check with the airline system as well. And once the booking done, then the agent should have to record our details somewhere to provide us some benefits in the next trips and all. So this is various use cases where the event streaming platform will come into picture. Okay, see here, to monitor patients in hospital care and predict changes in condition to ensure timely treatment in emergencies, right? So now in healthcare industry also a lot of healthcare devices evolved, right? So those are all using this um, event streaming systems. You know one thing, in the Apple mobile, you can send your health data continuously to the central health department. So what will happen if something happens? Then the central health department will something unusual happened with your daily activities, or maybe while you are traveling something, or while you are going from one place to another place. Your health is continuously monitored, and something happened, they'll take care of you. That's the beautiful benefit that Apple is providing for us. Okay, however, to connect, store, and make available data produced by different divisions of the company, right? You know one thing, in the bidding systems also, this event streaming platform will do a uh, lot of will pay a lot of work actually in the bidding systems, all right? And also in the betting systems, you can say, maybe in the streaming platforms, everywhere. Nowadays everywhere this event streaming platform uh, is needed. Okay, so these are all what. And one more thing, to serve the foundation of data platforms, event-driven architectures, and microservices, this event streaming platform can be used in the event-driven architectures, data platforms, and microservice architectures. So these are all what the where we can use this event streaming. Of course, we can see them as the use cases, right? So here is a description of few of the popular use cases for Apache Kafka. So for an overview, we can go and then see this blogspot. So Jake Reps explained very well about the use cases of the Kafka. Whenever, if you will get some time, go and then through it. But these are all what we discussed. They are all the use cases also. Okay, see this website activity tracking, metrics, log aggregation, stream processing. So these are all what the use cases. Okay, now let's go back to the these are what we discussed, right? Transportation, rider notifications, food delivery notifications, in the retail, sales notifications, real-time purchase recommendations, and tracking online orders. If we can the banking in the case, then fraud transactions detection, new feature are product notifications. So everywhere the event comes in, everywhere where the event comes in, event platform also require them, right? So those are all the use cases. Now let's enter into the Kafka terminology. So many questions you asked, right, on the messaging system. You guys are trying to understand, right? Here is the word discussion. Okay, now let us try to understand the terminology. Messaging system. Apache first will try to understand messaging system. Just now we have seen the differences between the traditional messaging system and then the Kafka event streaming platform. There we compared the messaging system with the streaming platform, not messaging system with the messaging system, right? Now see, what is messaging system? So Apache Kafka adapted a messaging system pattern to solve the real-time data integration problems. Here actually, the real word here is data ingestion. The real word here is data ingestion actually. But I changed it to data integration to make it more simple, because the word ingestion is a difficult word to understand. There's a lot of sense for it. I'll try to show you something. Let me go. Give me a moment. You can see this. So this is what the data ingestion or data integration framework or library or the tool what it is. What does it mean? It is a consumer to the Kafka continuously reading the data and making the data available to store somewhere. So what is this task is? This is doing an integration between the Kafka and then the some other storage server. So what it is doing, this is this is doing the ingestion. Ingestion in the sense what? Continuously taking the data and then making it available to store somewhere. That is the meaning of the ingestion. So now coming back to this one. Apache Kafka adapted a messaging system pattern to solve the real-time data integration problem. Here you understand, adapted a messaging system pattern. Why it adapted? What is this messaging system pattern? Now let us see. One thing is what? Why it is adapted to solve the problem of the data integration. Meaning real-time data, that is underlined. Real-time data, continuous data integration problems to solve, Apache Kafka used the messaging system. What is messaging system basically? How it will work? Now let's see. There are two approaches in the messaging system. One is point-to-point, second one is pub/sub model. Before this, I want to just read this one. For our retail chain example, a single invoice, this is the retail chain example we discussed, right? So a single invoice could be considered as a message. So messaging, we are discussing about the messaging system, right? So that means, what is the message? The every data produced, let's say this is producing one invoice, that is one message. This is producing one invoice, that is one message. So the data, whatever is the produced by the producer, is called as one message in the messaging system. It is called as an event in the event streaming platform, right? Okay, coming back to here. So typically it could be a JSON data or something similar, some UTF-8 readable format data. Okay, so there are two approaches to messaging. One is point-to-point approach. Second one is pub/sub model. So what is there in point-to-point approach? In point-to-point approach, in P2P messaging systems, this is built on top of the concept of the messaging queues, senders and receivers. So sender, receiver, and a messaging queue. Each message is addressed to a specific queue. Let's say producer is producing the category data, if you can see here, category service. Let's say what categories, how many categories of the products available in a retail store, that it is putting into this messaging queue, assume. So each message is addressed to a specific queue, and receiving clients extract the messages from their destination queues. This is point to point with these queues. So these queues retain all the messages sent to them until the messages are consumed or expired. These queues will do what? They will keep the messages with them until the message is either expired or until the message is read by the consumers. Once the consumer read the message, then the message queue will delete the message from its queue system. You understood? This is point-to-point. In point-to-point model, consumer connects to a specific queue, producer will produce the data to a specific queue. right? Now, P2P messaging has the following characteristics. Each message has only one consumer. Hey, all of you got one point. Now, I'm sure you might got one question, sir, product service connected to this rabbit. Similarly, payment service also connected to the same queue, right? Why you are saying only connected to one consumer, connected to one queue? Why you are saying that many other applications also connected to the same queue, right? Yes, connected to the same queue. But what is the benefit if the product product service receives the message? That's it. That message won't be available for other services. Then what is the point in connecting to the queue? Rather than connecting to this queue, common queue, they can connect to their own queue, right? At least to have the data, or at least to ensure that the data received by them only. You got my point? Hey, give me a moment. I'll plug in the charger. Yep. So you got my point, right? Every time I'm saying each message has only one consumer. What is that meaning? What is that meaning? Is the biggest pitfall in the messaging systems is once the data will be consumed by any of the consumer, that data won't be available to other consumers. Then what is the point for the other consumers to connect to this same queue of the product consumer? So rather than they do, what they can do is they can connect. Let's say payments can connect to payment queue, and transactions, or maybe some of the thing, maybe order service can connect to order queue, at least to ensure that they are receiving the data from their dedicated queues, because this messaging queue is what a single consumer point system. Hope you understood now. Okay. Sender and receivers are not dependent on each other. That is the beauty of the messaging system, right? That's the beauty. Now, coming back to the point, Kafka adapted messaging system. Why? The one of the beauty is producers and then consumers are decoupled. There is no direct interaction between the producers and the consumers in the messaging systems. That's what exactly the Apache Kafka followed, to decouple the producers and then the consumers, right? So the second point is what Kafka followed here. Okay. Now the third is the receiver acknowledges the successful receipt of the message. So once the consumer consumed it, then consumer will acknowledge the messages to the this messaging queue. So as the name suggests, P2P is more suitable for the one-to-one scenario. So Apache Kafka rejected this point-to-point approach because they wanted to address many-to-many requirements, right? So many other services can also consume the data from the same topic or same queue. So that is what that's what they were looking for, and then they went to PubSub model, not to P2P model. In PubSub model, what is happening? In P2P model, what happened? Producer is there, consumer is there, queue is there. In PubSub model, producer will be there, consumer will be there, broker will be there, extra broker will be there. In place of the queue, topic will be there. Extra what came in the PubSub model? Broker came extra. Okay, now you can see. Publisher. Any application that sends the data act as a publisher. That we know, right? In our POS, in our example, these POS machines are the publishers. So publisher, sender, data producer, everything is means for the same. That is publisher. And subscriber meaning an application that reads the data sent by the publisher is a subscriber. For our retail chain example, services such as shipment, loyalty, or the subscribers. That means this loyalty, analytics, shipment, finance, inventory, these are all the subscribers. So these are producers or publishers, these are the consumers or subscribers. Right? Now broker. This is very important in the messaging system PubSub model. So broker is the heart of the PubSub messaging system. The broker is responsible for receiving the messages from the publishers storing them into a file, and sending the messages to the subscribers. Right now, in the PubSub model of the messaging system, storage come into the picture. That's the reason the storing part is taken care by the broker. Right? Everything is same then. In the P2P, producer there. In the P2P, consumer there. In the P2P, queue is there. Here, in the PubSub model, producer there, consumer there. In the place of queue, topic is there. Extra broker came into the picture. Why? Because to store the data to make that available for many consumers, not to make it as a single consumer point. That's make this PubSub model is popular and adopted by the Apache Kafka. Hope you got it now, right? Now the difference between the messaging system, different between the PubSub model, probably you got it. All are you clear with this one? All are you clear?
But in queue also we kind of store the messages, and so it is kind of acting as storage, can we say?
Storage, but the problem is what? Once the consumer consumed it, it will
It is
be
deleted.
exactly. That's the problem.
And
But that
over here, even after consuming, it is not deleted, or after
ex,
7 days, it gets deleted, we can say, after some time.
ex, exactly correct. Yes, after retention period, it will be deleted. But it will be there even though the consumer consumed it. That's the benefit. Excellent. Yep. Hope you got the concept very clear. Great, great. No, thanks for attentively listening to sessions. Thank you so much for that. However, now let us see the architecture in a little more broader. Okay. The broker acts as a middleman between publisher and the subscribers. That's what we have seen. So Apache Kafka is a messaging broker, and everything that is integrating with Apache Kafka is a library or framework, is what we discussed starting of the session. See here, Apache Kafka is a message broker, and it offers a set of APIs to implement publishers and then subscribers. Now here you will confuse API, meaning you may be confused and then assumed it as a REST API. No, what I mean is, I'll explain this. Where that storage space will take, space will take on the machine, right? Where your broker is running, on that machine the storage takes place. Okay, perfect. Now let us go back to this one. We're talking about now this one. Apache Kafka is a message broker, and everything which is integrating with the messaging broker is a library or the framework. So we have such libraries. For the producer API, we have a library or the producer API we have. For the consumers, we have the consumer API. And for the to connect to the different source of systems to pull the data, we have the connect API. And to stream the data, whatever got onto the platform or the streaming platform, whatever the data come onto the platform, either by the producers, either by the connect, to stream it, we need the streaming platform, meaning streams API. So if you can see here, Apache Kafka is providing producer API, consumer API, connect API, streaming API. That's what here overview of this one. Now go back to this overview. What is those APIs mean? Go to the official documentation. You can see APIs. Kafka includes 5 core APIs. Actually, in the material, I have given the 4 APIs, but Kafka is providing the 5 APIs. I'll update the material. Okay. So the producer API allows applications to send streams of data. Consumer API is consuming the data. Stream API is transferring the stream of data. Connect API is connecting to the different source of systems and then producing the data. The admin API allows managing and inspecting the topics brokers. All the administrative activities are doing by this admin API. So producer API in the sense, if it is Java, then there is a dependencies offered by the offered for the producer API by the Kafka. If it is a different language like .NET, Python, there also they are giving the supporting libraries. For example, if you can see Apache Kafka with Python, there is plenty of the integration systems are available. The Kafka Python, meaning concept is same, but they were given some libraries like Kafka Python, maybe the library, right? So the concept of the Kafka is same, but they have given the different libraries to integrate with the different programming languages. So producer API is offering with one Maven dependency in Java. Similarly, consumer API is also offering with one Maven dependency. So when we include this dependency at the consumer application side, that means if you can see this, product composite will be having the library of what? Producer API, right? This Kafka-clients producer API. And consumer API also same, Kafka-client. So this is the library we can use at the producer side and then the consumer side, right? And then stream API. If you want to stream, then we have a streams API. And if you want to connect, then we have a connect API. Connect API is little different actually. The connect API allows implementing connectors. So we have the different connectors available. Like as I told, JDBC connector, file connector, different connectors are available. And we even can also create a custom connectors, right? So for example, if you can use the Spring Cloud theming module, that is itself implementing the connect API. Likewise, we can also customize this connect APIs. And then admin API, yes, there is again the same dependency Kafka clients is given. So this single dependency, if we add, it will provide us the producer API, consumer API, and then the admin API. Right? Hope you got it now. So this is what an overall Apache Kafka architecture. A high level architecture, not low level architecture, because going forward, we see a lot of low level architectures. So this is what a high level architecture. Excellent. Now you understood, it seems to be. Let's go and then start the installation process or the setup process. So we discussed why Apache Kafka, what is Apache Kafka, and overview we discussed. And now let's see the Kafka installation. So we'll end up with just a local installation, and in the next week we will continue with the storage architecture and multi-node installation storage architecture, and we'll continue all of these concepts. Okay, so now we'll see Kafka installation. Before going there, any questions? Anything do you want to discuss here before going there? Perfect, great. Now let's go and then see the any questions? My voice.
Sync connectors means?
Okay, there is a source and then the sink actually. So you can see here. Just to answer your question, see this sender who is sending the data, right? Called as a source. So we have a source connector to send the data. Similarly, receiver to receive the data, we have a sink connector. So source connectors, sink connectors are for the are used at the sender and then the receiver side to send and receive data. Okay. Yeah. Now let's go and then
cluster means multiple brokers, sir. Multiple brokers.
okay. Cluster means yes, multiple brokers. Correct. You can see in this architecture. Probably I missed that point, right? Yes, see this multiple brokers. Broker 1, broker 2, broker 3, multiple brokers. So
sir, each broker is for the one consumer, sir, like that, or otherwise one broker in the topic, multiple consumers can be there, sir, right?
it's a big architecture. So it's not one broker for one consumer. If you make it, then there is no point in adopting the portfolio, right? So basically, these brokers are the clustered brokers, replicated brokers. So what is the job of the broker? We discussed, right? The broker job is to take the whatever the producer is producing, that data the brokers will store. So when it is in the cluster, the data, whatever is coming from the producer, stored in 4 instances here. Broker 1, broker 2, broker 3, broker 4. Same message will be stored at 4 sites, 4 brokers.
Okay, sir. Same messages will be there in the 4 brokers, sir.
4 brokers. So if any broker down, right, then still
Yes,
data
sir.
will be other brokers. Yeah, that is what I am.
That means same topic will be there in the 4 brokers, sir. Am I right?
Correct.
Okay, sir. Okay. Yes, sir.
Yeah. Perfect. So let's go and then see the Apache Kafka installation. So all these documents I'll provide once you enrolled. Okay, I already created, just for you, I already created a classroom. So once all you registered, meaning whoever are interested, I have to say. So whoever are interested, once you registered, I'll get the list of your details along with your email IDs so that I'll add you here. Once I add here, you will have access to all my resources. Okay. Yeah. Perfect. Now let's go and then see the installation.
Sir, one query.
Hmm.
Sir,
Go
this Kafka cluster has a topic inside, and the topic has a partition inside it. I think
Correct.
in our earlier discussions, we mentioned that the topic cannot be replicated. But when it is a cluster, right, like Kafka broker 1, broker 2, and all, so broker 1 has the same pattern, and broker 2 can also have the same topic, right?
Correct. If it is a cluster, yes, same topic can be there in every broker. Yes.
Okay, you mean the topic is unique in one broker?
Exactly. That is what I mean.
Okay. Thanks, sir.
Okay. Now let's go and then see the Kafka installation. Kafka came in 4 flavors. Someone asked the question actually. However, 4 flavors. So open source Apache Kafka, and by taking this Apache Kafka source code, Confluent.io modified it and then added more capability on it like UI and all. Unfortunately, Apache Kafka doesn't have the nice UI. It is not shipping with a nice UI. That disadvantage has been taken as an advantage by these guys, Confluent guy, and then this, cloud providers. So open source Apache Kafka. Similarly, Confluent Kafka is also available, which is the customized version of Apache Kafka by the Confluent. So he is giving the Confluent Kafka in 2 versions again, community version and commercial version. We can try this community version basically, which is there for, I believe, 15 days or 1 month. I'm not sure, but we can try this community edition. And then the 4th one is managed services, like Confluent managed services is offering managed in the sense pay as you go model, like Amazon, Azure, Avent.io. So these are all what offering the pay as you go model. Every message they will charge. Every message coming into your queue or your topic, they'll charge a cent or maybe 5 cents or maybe 10 cents for every message. That's a huge business, right? In a day, thousands of events will come. Each event they'll charge. Basically. That's what their business model. Okay. So managed services are there and commercial distribution conflict. But we will target only the open source Apache Kafka. And if time permits, I'll also tell you how to install this Confluent Community Edition as well. But fortunately, in my R&D, I figured out one UI. It's a nice UI. That is Kardec UI. So this guy is giving a nice UI for us actually. We can download it. In fact, I download it. I'll explain how we can set it up. So now the Apache Kafka doesn't have the UI, right? That UI we can get it from this codec. It's an open source, which is very beauty. So then why we need to go and then pay for these guys, right? I mean, of course, those benefits are there. They are doing a lot of high availability, the maintenance, lot of hectics we can remove if you go with this managed service. But only the pain point is what each and every message they are charging. That is the pain point. However, in my course, we'll go with the open source Apache Kafka, and somehow if time permits, I'll explain how to use conflict. Okay, now download Apache Kafka. This is the official website. Go to official website. You can see get started. Let's say. Okay, let me go to this official website. Okay. Oh, here itself, download Kafka. Just download. Click on this. The documentation have the version 3.4 released on February 7, 2023, and see exactly a year released February 27, 2024, 3.7.0 released. So my document is with the version 3.4.0. The latest is 3.7.0, but still you can refer these documents because if any additionals or major things are added in 3.7, I'll document them as a separate document just for tracking what updates have been. Okay, but still you can confidently follow my documents. Fine. So what we can do here, see this released February 27, 2024, and you can see there is one observation. In 3.4.0, they didn't release the Docker image, but in 3.4, they released the Docker image as well. For Dockerizing and to manage it as a container, it given the Docker image as well, which is a very good thing. We don't have it in 3.4.0. Okay, what we can do now, we don't want the source code because we don't edit anything or we don't customize anything. So go to this binary downloads and Scala 2.12, Scala 2.13. So this Scala is what we built for multiple versions of Scala. They used Scala actually. I mean, building this Kafka product, they used Scala. So we'll go with either of these ones. Kafka 2.12. This is Kafka _ Scala version hyphen Kafka version. So either you can go with 2.12 or 2.13, that doesn't matter for us. So let me go with this Kafka 2.12 Scala version and 3.7 is our Kafka version. Just click on it. So it is downloading. Okay, down. Go to downloads. This is what. Let me take it to a C drive and put it into. And let me create one folder that is Apache Kafka binaries. You can use any of the drive, not only C drive, you can use any of the drive. But I chosen C drive because we're going to use the command line operations initially to explain the basic Kafka operation. So the command line operations have the full access on the C drives, right? Usually. So that's the reason I chosen this. Okay, just extract it using any of your favorite tool. I'm using the 7-chip. Extract here. Now again, one more zip came inside this. So go here and extract here. Now it extracted. So this is whatever Apache Kafka distribution, right? We done down. Next what? setup. You see one thing here, there is a bin. In the bin, lot of utilities were given by the Apache Kafka for different purposes. So if you go to Windows version, we'll have a lot of bad files here. We'll see the common things are mostly used things going forward. Done. Next what? So we downloaded and then we got it, we extracted. So these are all the steps done. Now go to bin, Windows. We have Kafka-config. Kafka-config, this one. Using which we can know what version of the Kafka that we done. So open the command prompt here. Kafka-config.bat -version. Oh, the input line is too long. Syntax of command is incorrect. Why incorrect? Kafka-configs.bat -version. Okay, here is the problem. The problem is in Windows, see, if this path is too long, somehow it don't detect the commands. I don't know whether that's a problem in it's a problem in Windows. I'm not sure, but what I'll do is let me copy this, put it directly under this C drive, or make the path simple. Now go here, go to Windows. Now let's go here and then Kafka-configs -1. Now the same command is working, right? Maybe that's the, if it is in the multiple folders, maybe the Windows OS is not recognizing it, maybe, but see this, now it worked. So what's the version? It is 3.7.0. But always we can't come to this Windows location where we have all the utilities, right? So we can't come to always this location and then check or use these utilities. We can use these utilities everywhere in the system, anywhere in the system. I mean to say, whatever the drive it is, C drive, D drive, whatever, right? So for that reason, we have to set it up with the environment variable. So how to set it up? So go to environment variables, go to more properties, advanced system settings, environment variables, create Kafka_home. Let me delete this for a while and create new Kafka_home. In Kafka_home, give till what is here before bin. Give till before bin. Okay, so go here, give till here. Copy this Kafka home and now go to the path. Okay, edit it. In the path, yeah, we don't have. Now create new percentile Kafka_home, then /bin/Windows, because that is the location where we have all the utilities, right? So we have to give /bin. Okay, so click on OK. OK, click on OK. Now we can go to any drive, any location, anywhere we can access those utilities. Let's say CMD. Now let me try to use this Kafka-configs -version. It should still, yep, it worked. So that's the benefit. Maybe you can go to D drive, go to whatever the drive you want, and then from there you can use these utilities. So that's the benefit of setting it in the environment. So you all know it. Right, done. Now setup is also done. So we installed, we done the setup. Now the next is what? We need to set up the Kafka cluster, the single node. Setup in the sense what? We just downloaded and then we just ensured to access those utilities. But we not really set up our architecture. To set up our architecture, what we need? We need the broker, we need the producer, we need the consumer, we need the orchestrator like Zookeeper or Graph, right? So all these are required. We didn't set up them. So let us go and then set up the single node Kafka cluster. I think it is too boring, right? Shall we continue in the next week, or is it okay to go and then set up the Kafka? I mean to say, if you bear with me for 30 more minutes, I can quickly show you the setup, and then I can show you this nice UI as well, right? So, but if you feel bored, then yeah, we can stop it and then take it the next week. Shall we continue?
Yes, sir. We can continue, sir.
Yeah. Great. Okay, fine then. Now see, let us set up a single node Kafka cluster. Single node in the sense only one machine. Okay, right now I have only one machine. So let us go and then node in the sense I mean a single broker. That's the point. Okay, so spin up a Zookeeper instance is a step one. Who is this Zookeeper? From where this guy got? So the name itself is saying is a Zookeeper, right? Zookeeper means what? He is the guy who can manage as the brokers, right? So what is the need of, okay, in the messaging system, PubSub model, we only got the broker, producer, consumer, broker, and then the topic. From where this Zookeeper came now? Whenever you see a cluster, there is an orchestrator required who will manage the cluster. Cluster in the sense what? Group of instances, right? For example, when you take the Kubernetes, there we have the Kube API manager who will control our kube control plane, who will control the Kubernetes instances, workers. Similarly, when you take a cluster, there should be an orchestrator or manager or a watcher or a dogkeeper or a zookeeper. The person required to manage the cluster. I think you are not. Okay, let me go back and then explain one. Go back to this one. So in the cluster, we have the many brokers, right? So what is the job of this zookeeper is, these brokers will go and then register with the zookeeper. Now the job of zookeeper is, if one out of these 4 brokers, one broker is acting as a leader, and that leader will manage the other brokers. These are the followers. So what the zookeeper will do is, zookeeper will manage the activities of this leader and then the followers in the cluster. Let's say one broker down who is the follower, then zookeeper will monitor it, and then zookeeper will inform to the leader so that the leader can manage the workload between the 2 available followers till the 3rd follower back to the team or back to the cluster. Zookeeper will monitor if the leader will go away or leader crash. The zookeeper will let all the followers know, hey, your leader died. Then among you, one of you is the leader. So zookeeper will make one of the broker as a leader. That's the job of the zookeeper. So it is managing the brokers inside the cluster. So from the Apache Kafka 3.4.0 onwards, or going forward, right now we are in the 3.7. So going forward, from the version 3.8 on, Apache Kafka wants to disregard this external tool. Apache Kafka wants to disconnect this store. Right now, what is happening is, right now, you can go to this pane, Windows, you can see Zookeeper. See Zookeeper. That means what this Apache Kafka is using some third-party library. Zookeeper is some other library or some other component they borrowed and then they are using here. So Kafka want to be a going forward independent one. That's the reason Kafka developed a one more orchestrator model, that is craft. Yeah, craft. So which is an alternate to the Zookeeper. And from 3.8 onwards, you only see this craft and you don't see the Zookeeper. So what we will do, we will set up our system with Zookeeper ones, we'll set up our system with craft ones. Both the ways we'll see. Right now, as on today, Apache Kafka supporting the Zookeeper, but from the version 3.8 onwards, they don't support it. It will completely disregard it and then only go with the craft. Okay, so don't confuse with the some other tutorials and some other things, whatever you have seen. So I'm just saying you by reading the official documentation. Okay. However, now let's go back to our setup. Okay. So we will see first the setup with the Zookeeper. Who is the Zoo manager, right? That means the cluster manager, brokers manager, right? So what we have to do, we have to set up this broker first. And before the broker setup, we need this Zookeeper available, right? Before the brokers, before the animals come into the zoo, there is a Zookeeper available to take care of these animals which are coming into the zoo. Similarly, Zookeeper is required here to take care of these Kafka brokers coming into the Kafka cluster. So first thing is what? Spin up Zookeeper instance. How to spin up? So let's go to any of the directory. Materials, trainings, materials. One moment, I want to create one directory here. Okay, let me create one folder. Kafka May 2024. Okay. Now here, let me take one more folder here. That is Kafka platform. Let me even go here, open a command. Okay, now what we need to do? We need to use spin up a Zookeeper instance. How we can spin up? What's the command? The command is Zookeeper -server-start config/zookeeper.properties. So that means what? We can get the Zookeeper properties from the config. Right? So these are all the Zookeeper properties. So I don't want to disturb these product files. That's how I'm just copying them to here to separate location. So from here, what I'll give is I'll use Zookeeper -starter Zookeeper -server -start then Zookeeper.properties. That's it. Zookeeper started. Right? Zookeeper is now started and then available. Okay, so what is there in the Zookeeper properties? Let's go and then there is a temp directory where all the zookeeper related data go and then store. And to the zookeeper, the Kafka brokers will connect, right? So the port at which the clients will connect to the zookeeper, that is 2181. And maximum client connections are 0. That means we are avoiding the limiting of the number of connections. And then disable the administrator by default to avoid port conflicts. Set the port to something non-conflicting if choosing to enabling this. Enable server admin dot enable server is equal to false. We are not enabling the server. We are enabling the zookeeper as an administrator only, but not administrator server. Server in sense where we'll get more capabilities like kind of a UI, or you can go and then see, right? So server administrators. What I mean to say is here, this enable server port 8080, if we enable, then we can access the zookeeper from the outer network, and then we can see. So I don't want to make this zookeeper to access from the outer network. Let the brokers in the cluster can connect within the cluster only, but not to the outer network. That is the point here. Okay, now zookeeper is ready. Then what next? So once the zookeeper ready, in the temp folder, we have to see the zookeeper. Where is the temp folder? Go to see. Oh, there is not temp. Go to here. Trainings. No Kafka platform. There should be a temp folder created. Let's see where it created. Hmm. Yeah, it created C users Narsi app data local temp. So this is the location where it created. Let's go to that location. We have to see here zookeeper. Date modify. Hmm. 25. Actually, we have to say zookeeper. Okay, let me stop it. Okay, and let me run it from the C drive. That's all right. So administrator access always will be in the C drive. So what I'll do is, let me create one more directory here, like Kafka platform, and let us copy this zookeeper file to their Kafka platform, and let's open the command from here and then run zookeeper hyphen server hyphen dot bat hyphen hyphen sorry dot bat zookeeper dot property. I think hyphen because we are passing it as a command line. Oh no. So just zookeeper dot properties. That's it. Let's see. Before this, why can't I clear my template?
Server that property we need to pass it while starting zookeeper or
Correct. We need to,
zookeeper that
oh sorry, zookeeper dot properties is what we need to pass.
okay sir, okay.
I mean, did I say server dot properties? Say that is typo. Zookeeper dot properties is what we need to pass. Let's see. Earlier,
Okay
did we
sir.
pass server dot? No, zookeeper dot. Okay, yeah. Okay, so I'm just deleting this temp also for a sake to see the latest data here. I have a lot of temp files. Let it just bear with me. About to finish in just 5 seconds. Oh, 15 seconds. Okay, just bear with me. Almost done 88%. Okay. Yes. So almost done. Just bear with me. Okay. Meantime, what we can do is we can go to our command line, right? And then we can pass zookeeper.properties. Enter. Perfect. Now zookeeper started. So where the zookeeper creating this temp location, go back to see this temp we got, and there you can see zookeeper. That is the reason I'm suggesting to go with the C drive, because the permissions you will have to create the directories and then write the data. Because we are following what PubSub model. In the PubSub model, our Apache Kafka is acting as a broker, and then broker wants to store the data. In order to store the data on the device or on the machine, it needs the permission. That's the reason go with the C drive. This one. Okay, I'll also show you how it will be in the Linux. That next week we'll see the AWS. Okay, so now see this zookeeper and version 2. Here the zookeeper file. Right now it is 0.01 KB. Let's go on 0th file and then the 1 KB. We even can't see that. Okay, no problem. Now zookeeper is ready. Go back to architecture. What is next in the architecture? Zookeeper is ready. Now the broker. Okay, so let's go and then set up. So you can see why the temp/zookeeper folder created here, because in the zookeeper tag properties by default it is here. If you want, you can change it to anywhere. That's fine. Now spin up the Kafka broker. How to spin up? In order to spin up, we need the server tag properties. So what I'll do is I'll go back to again our Kafka config. I'll go to the server dot properties, copy this, come back and then paste it here. Okay, and open the server dot properties. See what it is. The ID of the broker. So this must be set to unique integer for each broker. Whenever we are setting this broker in the cluster, right? As I have shown here. So broker ID is what the uniquely recognizing broker in the cluster. Also, zookeeper will identify the brokers with the broker ID. So IDs are important. Let's not give this 0, rather let me give the 1, broker 1, I mean to say. And so number of network threads are 3. About these points we'll discuss later. Okay, it is too early to discuss. These are all the points going forward. In all these properties, but only one property is what number of partitions. One log directory is again temp directory. Okay, this is the only thing. About these partitions we'll discuss. Right now the partition is only one. Okay, now what we can do, again we can go back to the platform location, open the command prompt, and then what's the command? Kafka-server-start.bat. A quick question. Okay, I'll ask. Kafka-server-start.bat. A quick question. All these utilities are in the product binary directory, right? Product bin directory, and their Windows. I mean to say all these binaries are available in the product distribution binary directory and in Windows. How we are able to access it in our platform directory or in the D directory? Because we set it up as an environment variable. Okay, remember that. Don't confuse. Okay, Kafka-server.bat. Then what we have to give for this? Server.properties. Now see, it will register with the zookeeper and then broker with the ID 1 created. So you can see this. Brokers/IDs/1 is created with the port 9092. Okay, if you want to create one more broker, what we have to do? We have to create the server properties file one more time, and then we have to change the port number. Where is the port? This is the zookeeper port, and we have to change the port number. Port number. One moment. Yep, you can see here. So this property we have to enable, and then we have to change the port number, right? So that what will happen? One more broker will spin up with a different. Now only one broker, one zookeeper, right? So now that done. So we have the cluster done. Of course, cluster, I don't want to use the word, but one broker we set up, and then the zookeeper we set up. Okay, let us also set up one more broker so that we can term at least it as a cluster, right? So let me go down. One more thing. Go to temp directory, and you can see Kafka log. There we can see this Kafka logs and zookeeper version 2. There is one log recorded, and this is an unreadable log, but one log record. Okay, Kafka logs. Yeah, these are all the Kafka logs. Okay, that is one mistake I did actually. Okay, so what I'll do is I'll stop the broker because we thought of setting it in a meaning we thought of setting it in a cluster, right? So let me stop this. Okay, what we will do is let's go to server.properties. Go to 10 Kafka logs. Okay, now let's go back to the Kafka platform, server.properties. Unfortunately, this file is, I opened this log, right? So that's how it is taking a lot of. So let me close my notepad. Yeah. Now let me open this server. Okay. So here, what I'll do is I'll create this as the broker one. Okay. The log directory is broker one. Let me create it as. And the server name also, let me take it as the broker one. Similarly, let's go and then enable it with another name, broker 2. And when it comes to the broker 2, in broker 2, let's take this as broker 2, and broker 2, to avoid that port number conflicts, let's enable this listener with the 903. Okay, makes sense, right? Now everything is
So
fine.
broker ID, sir.
Oh yeah, broker ID. Thanks for this. Broker ID is 2. This is the second one. Excellent. Broker 2, broker ID 2, and then the port number we changed to our do. Excellent. Okay, now what we can do? Now let's open the platform, and let's say Kafka server start.bat, then pass the broker. Excellent. Now broker 1 started. Once broker 1 started, we can see the temp broker 1 logs here. Perfect, right? Now let's go back to one more time the platform, and then open the command prompt again. Kafka server start.bat broker 2 this time. Broker 2. Awesome. Broker 2 also now started. on the 903, and you can see broker 3 logs also here. Sorry, broker 2, I mean to say, my bad. Broker 1, broker. Now going back to the UI. Okay, so at least you can see the cluster how it is. Now the cluster created, right? So how the cluster created now? We have the zookeeper, we have broker 1, broker 2. N number of brokers you can create, right? At least we can say now it is a cluster. Now what we can do is, let's go and then see it in a UI. For that, this codec is what the uh, organization who is offering a free software for us for use this for the purpose of the Apache Kafka UI. So what I can do is, let me put it in a let me create one here, Kafka UI, and let me add a link here so that tomorrow you can come and then go to this link directly from here and then down. Right? So Kafka UI you can download. So what we can do is click on this Kafka codec for desktop. Click on this Windows. Okay, so when you click on it, it will download. So let it do. It is downloading. It's done. Now go to down. Take this one and go back to our platform. Let's keep it here. And let's extract here. Okay. And let's rename it as the Kafka UI. Otherwise, we don't know what is this. Kafka. Now go here. There is a codec application. So just run it as an instance. If you want, you can also read the EULA, end user users license agreement. This is the EULA. So here he clearly mentioned, because before you I read these terms and conditions, clearly mentioned with the free license for the carded desktop free edition, the user receives the royalty-free, non-exclusive, non-transferable, and non-sub-licensable right to install and use the software on one computer. The software runs on the local instance and is not a cloud or a web-based service. So he's given the right to install it. But what he's saying is, if the user acquires the CAD desktop free edition, the following limitation of liability shall apply. What is that liability? In case of injury to life, limb, or health, Exotech is only liable for intent and gross negligence unless the injury was caused by a defect. That means what? We are running this one, right? We installed and then running this one. Right? If the product corrupted or with the virus or any other reasons, the product corrupted, then these guys are not taking the liability. We are not responsible because we given it as a free for you. You used it. Now some crash happened to it. We can't go and then ask them, right? Hey, Exodec, what is that? Zoetic team, give us the paid, give us the backup of my data. How they will give? They're not responsible. That's what he's saying. But other than that, we can happily run it as a software on one machine. Okay, cool. Now go back to here. The same EULA, end user license agreement, is given here. I hope we read whatever we want and then confirm the agreement. So just register yourself. I'm registering as Narsi My Teaching. Narsi.myteaching@gmail.com. company is something, and then company is an optional, I believe, but whatever you want, you can put. And software architect is what my role. How we do here? Social media. Oh, I came to know here through the Google. Accept and then submit. Perfect. We logged in. Now add a connection. Apache Kafka. Click on next. And let's say let us consider one application, right? Let's say we Shopify app streaming. We Shopify app streaming platform. Okay, now what are the bootstrap servers where they are? 127.0.0.1:9092 is one broker, and 127.0.0.1:9093 is another broker. Test connection. Connection must specify a port. Okay, probably we supplied this as well. Okay, let me just cancel this and then come back. Apache Kafka. Next. Comma. We have to give comma separated. Okay, so let me give the comma. 127.0.0.1:9092. Our broker one. 127.0.0.1:9093. 127.0 local host. Now do a test connection. Yep, connection to Kafka was successfully confirmed. Create. Connection created. We Shopify app streaming. So this is our platform, right? So we Shopify streaming. Now we can go and then see connection information. We can go and see monitoring overview. I think few things he given as free, but at least we can go back and then see our. Okay, fine. Right now we don't have anything, right? Right now we have the two brokers. That's all. Yeah, right now we have the two brokers, and probably we'll get more information as we use the broker. Data catalog, data browser. Yeah, so our topics will come here, right? You can see here data browser. We don't created a topic yet, right? So once we create topic, our topic will come. Okay, so let's create a topic. Stay tuned. Let's create a topic. Interesting, right? Crazy. So let's
Yes.
create. Yeah. So how to create the topic, just in case, for a basic things to see how they are working. Now we have done the setup. Zookeeper done, broker done. Now the topic we need to create. So how to create a topic? Let me again open the command prompt. And the command for topic is what? Kafka-topics, bootstrap server, localhost :9092, create topic. We can also use comma 9093 as well. We have the two, right? So what we can do is go back to command line, Kafka topics back, localhost :9093, localhost :9093, create topic. Let's say I want to create orders topic, partitions are 1, replication factor is 1. I believe We have to discuss these all the things, right? In our Kafka storage architecture, we're gonna discuss what is the topic, what is the replication factor, what is the partition. Hey, where is this? One. Something went wrong, right? So the command specifies hyphen partitions and then the replication factor. Yes, now let's create it. Oh, replication factor is not recognizable option. Really? Yep, replication factor. What? Replication factor is not a recognizable one? Am I giving the right one? Hyphen replication. Oh, replication hyphen factor.
Hyphen factor.
Yeah, typo. Replication hyphen factor. Awesome. Now topic is created. Go back to our tool. Just refresh. Oh yeah, order topic is created. Right? But nothing is there. Right? Current view is the default view. Nothing is there. So if you want to see what is coming, consume live data. So see, trying to consume live data, but nothing is here. No producers, right? So nothing is here. How beauty. Now our topic is ready. Our brokers are ready. Our zookeeper is ready. Everything is ready. Now we want producers to produce the data where we can see the data continuously here. This is real time. You can see this is what real time is. Okay, continuously listening for the data here. So same consumers also do the same. They'll continuously listen. Okay, let me stop for a while. Next
Sir,
is
how to
what?
see this topic belong to which broker?
Okay, this topic belongs to which broker? Actually, it is belong to both the brokers, but we should have to see here. We can describe this topic. I'll describe this, meaning we have a command to describe the topic. So let me see that, but I'm just looking, did he given anything here? Okay, he didn't give it, but we have a command to describe. So let's go here. Let's say Kafka hyphen topics. Let's give the command. Okay, so give the command Kafka hyphen topics hyphen. Okay, so topic name. Oh, let me just give describe illegal argument. Okay, so let me pass hyphen to keeper space localhost colon 2181 is the zookeeper port number, right? Then let us describe. Oh, what is this? Outputs. There is a describe.
List command.
List is to list the data in the topic. We have a
Okay, sir.
Yeah, we have a describe also. Okay, no problem. Let us see this hyphen here. List, yeah, hyphen describe. List details for the given topics. Hyphen. Oh, why are you taking this? Okay, 1 minute, guys. Okay, so simply in the place of the create, I can use the describe simple. That's it. See, now what happened? There is a partition 0, there is a leader 1, there is a replicas 1, order topic, topic ID, partition count, replication factor. Should give us, right? Basically, this, okay, let's go and then see in the temp directory, broker 1, we have a order topic, okay? And same replicated to broker 2. Oh no, oh yeah, this is belongs to only broker 1. Why? Why it didn't came to broker 2? Because we didn't given the replication factor. We given replication factor as only 1, right? Partitions we only give 1, and replication factor we only give 1. That's the reason it didn't came. Let me give replication factor is 2, and then let me take this as now the payment stop. Okay, now let it create. Okay, now we can see payment topic here in the broker 1. Similarly, payments topic in the broker 2. So by navigating through these directories, we can to know, and somehow this tool also should have to give us basically what are all the brokers, right? This is giving the topics information. Two topics only. Okay. So okay, I'll explore more this tool, but it is nice tool, it seems to me, where we can see the data and all. Okay, so let me go and then see. This monitoring is not given the free version, and this is the data catalog. Okay, data catalog, you can see pay orders topic, payments topic, and then consumer offsets. About this consumer offsets, we'll discuss later, but you can see the payment topic. In this topic, partition is 1. I think is given. It just given about the topic. Records are 0. Only one partition. No owner. And this is the topic configuration. Okay, I'll explore more. Definitely has to give in which broker these topics are. So replication factor 2 is what is given. In which broker it didn't mention here. Yep. Okay, so we created the topic, we created the topic, we created the broker, we created the zookeeper. Now it's time to produce some data. So what we'll do is let's live listen. Go here. Let me choose the topic, order topic. Okay, order topic is live fetching the data. So let's go here, send some data. Okay, in order to send some data, we're all using the APIs, right? So we need this command specifically. So producer command, producer dot broker list, and then topic, property, and then some value. Let's say copy, go here, paste anyway. Okay, so Kafka console producer. One more point I have to explain. So Kafka given the console utilities, console producer, console command, console producer, console consumer for us to produce and then consume the data from the command. So console producer broker list. Here the broker list we can give localhost colon 9093, and then topic is orders topic, right? So let's go here. Orders topic. Order cycle. What is this? Am I missing anything? Typo? Yeah, obviously. I gave typo. Just copy, paste it here. Console producer. So here, localhost 9093. Topic is orders topic, and property key separator, and then parse is equal to true. This is what we have to give. Let me do this. Yeah, now see. So let us do a live. Go to here. Live. Now let's see. Apple. No key separator found. Okay.
కడుగుతాను ఒక్క నిమిషం.
Yes. Can you please mute? Okay. Now we send the data. We have to see the data here. Let's say P. O. Are we getting the data? You can see here Apple and then Bob, right? So let me send CCAT. Yep, CCAT is there. DDoc. Yep, DDoc is there. Cool, right? So producer is producing the data, and that data is now storing at the broker side. And when consumer came, the consumer can consume this data, right? So this is what the live. This is how the live real time will work. That's all, guys. So I don't want to really bore you. It's a lengthy session. So, however, so what we discussed, we completed the Kafka single node cluster setup. Next week, let us work on setting up this Kafka in the AWS cloud with the multi-broker, multi-cluster. That's all from my side. Any questions for me before I'm leaving? Great. So anyone of you interested, go and then do your presentations. And about how many days these videos will be available, just check with the backend team. I believe it is into, if your course is 1 month, right, to 4 weekends in a sense, maybe videos will be available for 8 weekends. I'm not sure. Just go and then check with them. Yeah. So that's all, guys. Any questions for me?
Sir, whatever to set up this Kafka coder, we need to copy that complete folder, sir, in that one.
We need to download it, and then we need to keep it anywhere. Say I just copied it to Kafka platform folder, extract it, and then just run. That's it. Okay,
Okay, sir. To run the brokers, we need to give like, okay, sir. To run the brokers, we need to give like a server.properties, sir, right, sir?
Correct.
Server.properties for while running like a Kafka server command.
Correct.
Sir, you have copy pasted those Kafka under platform folder you pasted, right? How they work? They are working, sir, even though it is not. Can you?
Because we set up the environment variable, right? So here we have set up the environment variable with the, sorry, let me show you.
Yeah, Kafka home.
Yeah, Kafka home we set up, right? So because of that, we are able to access anywhere. Got it? Do you still want me to show that?
No, sir. Fine, sir. Fine, sir.
Yeah, fine.
Sir, these videos are available, sir, today only, recording sessions, sir.
This will be, I think this demo 1 and demo 2, they will upload to the YouTube. So those will be available in the YouTube anywhere,
Okay, sir. Okay.
anytime. And whoever registered, right, for the registered student, they will give the drive access and I will give the material. So
Okay, sir.
once
Okay.
I probably will get the list of students, maybe end of the Tuesday or maybe end of the Monday, I don't know. But once they gave the list of students who enrolled for this one, then I'll add you folks to this Kafka classroom so that you can access all the materials, softwares, everything.
Videos also, right?
Videos, no. Videos are not from here, but videos will be uploaded to your.
Okay.
Drive, sir, in the drive, right, sir?
Yeah, in the drive, correct. You will register with one email ID, right? In that email drive,
Yes, sir.
the videos will be uploaded. So, in case if you are if any of you are interested and then registering, right, give the proper email ID. So to avoid
Yes, sir.
this.
Already we registered. Already I registered, sir. Actually, so that may. When will I get the videos, sir? Videos and this material by Tuesday?
Yeah, by the Tuesday, I'll check with them. But for the paid student, maybe you will get the videos upfront. Maybe today only you will get it. But the
Okay, sir. Okay.
materials, I'll take 1 or 2 days and then provision the materials.
Okay, sir. Okay, sir. Okay.
Yeah.
Sir,
Okay,
what is the
folks.
live, sir?
Yeah.
Here live is there, na? There is an option live is there. You are sending the message. What is
Yeah.
that live option?
Real time, live in the sense, see, when the producer is producing the data, here the data is consuming by this broker, right? The broker is acting as a consumer here. So assume this is a consumer. Now live in the sense what? While we are producing the data, here the data is consumed. It's a live. How you are producing, it is
Okay,
consumed.
sir. Okay.
Right? So it's a live streaming.
Okay, sir. Two brokers, both two brokers consuming the data, sir, right?
Correct. Actually, we have given for the orders topic, we have given replication factor only one. So it is consuming only one broker, that is localhost 90. So we have created one more topic, right? That is the payments topic with the replication factor 2. In that case, both the brokers will consume.
Okay, sir. Okay. Replication factor should be 2 in that case. Then, okay, sir. Okay. The message will be available in the two brokers, sir, in that case only.
Correct. Brokers in that case, yes.
Sir, one more doubt. Number of brokers equal to number of replication count, sir? Replication factor.
And no, actually, Kafka recommending, the official documentation is recommending replication factor should be less than or equal to the number of brokers. Less than or equal to.
Okay, sir. Okay.
And also see this. The replication factor, with about this replication factor we'll discuss in detail. But what the official documentation is saying, see this, we recommended you use a replication factor of 2 or 3. No matter your brokers are 5, 6, 10, but suggesting to use replication factor of 2 or 3 so that you can transparently bounce. I'll explain this. Why they given this recommendation. I'll explain when the topic comes. Okay, but the replication factor should be always less than or equal to number of brokers. It shouldn't be more than number of brokers.
Yes, sir. Fine, sir.
Perfect.
Sir, partitions also can be anything, sir. Partitions can be any or only one only, sir.
No, it can be any 20, 30, 100. But what are these partitions we have to know, right? So we'll discuss them. What are Kafka storage architecture? You will see complete anatomy about the topic. So there you will understand better why this is important in the question basically. Replication factor versus partitions. Okay, so great guys.
Sir, okay.
Thank you so much. I don't want to take your much time. Happy Sunday, and hope to continue to see you.
Sure, sir. Thank you, sir. Bye.
Thank you, sir. Thank you, sir.
Thanks a lot. Thank you.